So what is easy water? It's a different structure of water. No, liquid water consists of water molecules. We've all seen them, you know, an oxygen and two hydrogens. And the water molecules are randomly arranged in liquid water, and they're bouncing around fiercely at a gigantic number of times per second, or even per femtosecond. Easy water is different. Easy water is a bit like a crystal, very well organized. And the structure of this crystal, we found from various experiments, is a sheet-like structure. So starting from a material surface, you find that the liquid water molecules will convert into a sheet of water. That sheet is adjacent to the surface. And it's a hexagonal sheet. It's a honeycomb-like structure. So what is the fourth phase of water? You know, we think of the phases, the known phases of water, as solid, liquid, vapor. We all learned that from the time we were in middle school. But the fourth phase is different. You might say it's somewhere between a liquid and a solid. It has the consistency of honey. A viscous or raw egg white, for example, which is indeed fourth phase water. So it's in between a solid and a liquid. And perhaps the best way to describe it is as a liquid crystal. You know, crystals are substances where there's great organization. This has great organization, but it's not a solid, it's not a liquid, it's liquid crystal. So that's how we would describe this fourth phase of water. If you don't have enough easy water, you have a pathology, because the cells can't do effectively what they need easy water to do. And one example of that is cancer cells. So if you follow the logic for a moment, an ordinary cell is a healthy cell, has a lot of easy water. Therefore, it has a high negative electrical potential, minus 90, minus 80, minus 100. Cancer cells, it turns out, have a low negative electrical potential, minus 10, minus 15, minus 20 or something like that, which means that they don't have a lot of easy water. Well, it was found about 50 years ago that if you ask the question of what causes cells to divide, a guy named Clarence Cohn, respected investigator, found that when the electrical potential of the cell is very near zero, instead of minus 90, it's maybe minus 10 or something like this, that prompts cells to divide, even ordinary normal cells. Cancer cells have exactly that electrical potential, minus 10, minus 15, depending on the particular cancer cell, which means they're short on easy water. And therefore, they keep dividing, and therefore you get a tumor. So then what derives from that is that if you want to deal with cancer in say a preventive or therapeutic way, what you need to do is build easy water. The logic follows from that. And some of the ways of building easy water are already used to treat cancer, but in a more general context, what you should be doing either to prevent cancer or to reverse the cancerous cells is build easy water.